Astronomers around the world have been paying close attention to a mysterious object moving through our solar system, one that has quickly become a topic of heated debate and fascination. Known as 3I/Atlas, it is only the third confirmed visitor from interstellar space ever detected, following the famous Oumuamua in 2017 and 2I/Borisov in 2019. But unlike those earlier objects, 3I/Atlas has already shown behavior that is confusing experts and sparking theories ranging from unusual cometary activity to the possibility of advanced extraterrestrial technology. First spotted in the summer of 2025, the object immediately stood out because it did not behave like the typical comets astronomers are familiar with. Comets normally develop a bright tail made of dust and gas that streams behind them as sunlight warms their icy surfaces. But this new interstellar traveler has defied those expectations. Instead of trailing a glowing tail behind it, 3I/Atlas appears to have its brightness concentrated at the front, creating a forward-facing glow that has left observers puzzled. NASA's Hubble Space Telescope provided the clearest image of 3I/Atlas on July 21, 2025, capturing the strange luminous haze surrounding it. The coma, the cloud of gas and dust around the object, was positioned in front of the nucleus as it approached the sun, almost like a headlight rather than the drifting cloud seen with traditional comets. While evaporation of surface ice can create a coma, the absence of a tail is unusual and difficult to reconcile with standard cometary physics. This unexpected signature forced many researchers to reconsider what they thought they knew. Instead of behaving like a natural chunk of ice and rock, the object seemed to be performing its own version of physics, something not easily explained by ordinary models. Among the most vocal scientists engaging with these anomalies is Harvard astrophysicist Avi Loeb, known for offering bold interpretations even when they challenge mainstream thinking. Loeb noticed that the way 3I/Atlas brightens does not match the expected light curve produced when sunlight reflects off dust. Typically, dust reflects sunlight in a predictable gradient, with brightness gradually decreasing at a certain rate. But in the case of 3I/Atlas, the decline in brightness is extremely steep, suggesting the light source might be concentrated in the nucleus itself rather than in a cloud of reflective particles. This observation led Loeb and his colleague Eric Kito to propose that the object may be producing its own light, which would set it apart from anything seen before in natural celestial bodies. If the nucleus itself is luminous, then 3I/Atlas could be far smaller than earlier estimates, perhaps under 100 meters in size, similar to the other interstellar objects previously discovered. Such a small object emitting that much brightness requires an explanation involving far more than sunlight. Loeb went further, calculating that the observed glow would demand roughly 10 gigawatts of power, on the scale of a massive Earth-based power plant. Natural objects rarely produce energy at that level unless they involve extreme phenomena. A black hole fragment, for example, might radiate energy through Hawking radiation, but such a black hole would release far less power than needed to account for the observed luminosity. Another possibility Loeb analyzed was a radioactive shard originating from the dense core of a supernova explosion. Supernova remnants can indeed contain exotic materials capable of emitting tremendous amounts of radiation. Yet such fragments are thought to be extraordinarily rare, and to find one drifting into our solar system would be an improbable coincidence. With natural explanations stretched thin, Loeb raised the most provocative theory. Perhaps 3I/Atlas is not entirely natural. He proposed that it could be a spacecraft powered by nuclear energy, shedding dust it collected throughout its long interstellar voyage. Such an idea may sound extraordinary, but Loeb argued that extraordinary observations sometimes require bold hypotheses. His suggestion echoes the debates surrounding Oumuamua years earlier, when he argued that the unusual acceleration and shape of that object might indicate artificial origins. The trajectory of 3I/Atlas has added even more intrigue. Instead of taking a simple, straightforward path through the solar system, it has passed unusually close to both Earth and Jupiter, almost as if weaving through key planetary regions. While gravitational interactions can bend the paths of incoming objects, The pattern of its course has raised eyebrows among scientists looking for anything that might hint at non-natural motion. The most notable upcoming event is its flyby near Mars on October 3rd, when it will pass within about 29 million kilometers of the planet, a relatively close encounter by astronomical standards. This presents an unprecedented opportunity for a detailed investigation. NASA's Mars Reconnaissance Orbiter is already preparing to observe the object using its powerful high-rise camera. Since Earth-based telescopes will have difficulty viewing 3I/Atlas at that time due to its position near the Sun, the Mars orbiter may provide the best, and perhaps only, chance to capture high-resolution data that could resolve many of the lingering questions. Despite all the unusual features surrounding 3I/Atlas, most astronomers remain cautious. Extraordinary claims require extraordinary evidence, and many experts prefer to start with the simplest explanations before considering exotic possibilities. UCLA astronomer David Jewett, who played a major role in analyzing the Hubble observations, suggested that the lack of a tail might be explained by evaporation occurring mostly on the sun-facing side of the object. If the material being released consists of extremely tiny ice particles, they could sublimate nearly instantly, disappearing before they have time to disperse into a traditional tail. This could produce the forward-facing coma observed by Hubble without invoking unnatural mechanisms. Jewett's interpretation aligns with how many scientists approach anomalies. Assume the object behaves within known physical laws unless proven otherwise. Even so, not all aspects of the object's behavior fit comfortably within known models. The steep decline in brightness remains a persistent challenge. Normally, dust particles scatter sunlight in predictable ways that produce smoother, more gradual profiles. The sharp drop-off seen in 3I/Atlas fits more naturally, with a compact luminous source at its center rather than a scattered field of reflective debris. This discrepancy continues to fuel debate among astronomers and physicists. Loeb maintains that ignoring the luminous nucleus interpretation would overlook a potentially significant clue. Throughout his career, he has argued that humanity should be open to the possibility of technological artifacts from other civilizations, especially given the vastness of the universe and the likelihood that many stars have produced planets older than Earth. The growing debate around 3I/Atlas mirrors the scientific storm that surrounded Oumuamua 8 years earlier. Oumuamua exhibited several confusing traits, including an unexpected acceleration that could not be explained by cometary outgassing, and a strange flattened shape unlike any known asteroid or comet. Loeb argued then, as he does now, that the simplest explanation might actually be artificial. Most scientists rejected that conclusion, preferring models that pushed the boundaries of natural phenomena rather than invoking alien technology. Yet, with every new interstellar object discovered, the mystery deepens. If 3I/Atlas turns out to share properties with Oumuamua, the case for unusual origins may grow stronger. As 3I/Atlas continues its journey through our solar system, the scientific community watches closely, anticipating what upcoming observations may reveal. The Mars Reconnaissance Orbiter's planned imaging session could become one of the most important astronomical investigations in years. Any high-resolution data, whether confirming unusual behavior or proving mundane explanations, will provide valuable insights into interstellar visitors. If the object behaves like a traditional comet, the mystery may fade. But if new data reinforces the anomalies, the debate may intensify, pushing scientists to confront possibilities that once seemed speculative. For now, 3I/Atlas stands as a symbol of scientific curiosity and the limits of current understanding. Whether it is a strangely behaving comet, a fragment of exotic astrophysical material, or something far more extraordinary, it reminds humanity that the universe is vast, unpredictable, and filled with secrets waiting to be uncovered. Every interstellar visitor carries the potential to reshape what we know about the cosmos, and 3I/Atlas might be the most intriguing one yet.